So with this, guys, let's get started with the combiner and the partitioners. What we are going to see today is we are going to see the demo of this. The first thing, like which we discussed. If you remember the last class, we discussed about the Mapreduce program, and there we use the custom partitioner, and that's what like today the question Vikas has, that if we don't write the partitioner, it will use the default partitioner, and the answer is yes. It uses the default partitioner. But what if your the requirement is in such a way that you have to basically the segregate the data which you are getting from the reducer. So it may happen like this way, like since all of these reducer writes its output in one particular file. So what you can have is like if you use the default partitioner, it is going to basically calculate the hash value, and based on that hash value, a particular reducer is going to get a key, and then it's going to process that. So it may happen like two of the data set, two different key may have the same hash value, and based on that, it will go to the same reducer, and that's where the processing will happen together inside one reducer, and you will have the data set coming basically mixed in the output reducer file. Now think of like if you have the two basically you have the multiple the company which you are basically providing the service, and whatever the transaction log you get, you do some kind of the processing based on like how much they are using the service, or whatever kind of the processing you do. And once it comes to the output, if you want to store all those output basically in a separate file, so that you can create a HIVE table or something on top of the data and do the analysis. So to do such kind of stuff, what you will end up is like you have to define like each company has its own key, or based on that key only you are processing the data. So if you want to have your own logic, how you will want to see the output data in different files, what you can do is you can write the custom partitioner, and with the help of the custom partitioner, what you can do is you can segregate the reducer output data set. So when it comes to basically writing the or implementing the custom partitioner, you can basically use two things: configure and the get partition. So by using the get partition, what you do is whenever you run this Mapreduce job, you write the logic like how your data is going to be segregated based on the logic which you write, and that's going to return a number between 0 to the number of the reducer which you specify, and based on that number you are going to basically identify which particular reducer this input data set is going to be sent. So during the shuffling phase, it will use the logic which you have coded in the partitioner class, and then that based on that particular logic, it is going to move the data from the mapper to the reducer. Right. So this particular stuff, guys, is useful only when you are dealing with the multiple reducer, and you need basically a mechanism to determine which particular key value pair you need to send from the mapper to which particular output. So in that case, you are going to basically code this logic of the partitioner. Right. And if you don't code this particular logic, what you are going to have? You are going to have the default hash partitioner. So that's basically going to create the hash value and then move the data. Okay, so without having much delay here, guys, let me show you the demo of this one, and I think that will really add clarity here, how to write this combiner and the partitioner logic. The program which I'm going to use is going to be similar with the word count example which you used, but it is going to have its own the custom partitioner and the the combiner. Okay, so that in case if you guys have missed or not or didn't get a chance to practice this Mapreduce stuff, you can do that as well with this particular implementation. And along with that, you will also learn the two more concepts. That's basically how to implement combiner and the partitioner. Okay. So what you are going to do as part of this implementation is you are going to write your own logic for the partitioner, and the logic whatever is there for the map and the reduce, it is going to be the same. Okay. So let me take here. Okay. So if you guys remember our last class discussion, guys, so what we discussed about the Mapreduce framework is like you implement mapper, you implement reducer, and then you implement something called the driver class, and that's where your whole execution is start. And based on that execution, whatever you specify the mapper and the reducer, it will take that and and do the word count example. So the few things what you do here is like when it comes like you create a configuration object, and based on that configuration object you set first like the job name, and that will basically you use it to display it on your job tracker. So you specify this word count, and based on that it will display in the job tracker. Okay, so you have this the configuration object, and then you set the word count. So that's exactly similar. What you see here, guys, is this is like how you specify the number of the reducer. So generally, the number of the mappers which you are going to have in case of the Hadoop Mapreduce program is guys, it's going to be determined by the input data set which you have. So based on your input data set, you are going to determine how many number the framework is going to determine how many number of the mappers it will run based on the split and all. But the number of the reducer you want to run inside your Hadoop program, you can always specify either through the program or from the command line as well. So here you have one way to specify the number of the reducer. You can set the number of the reducer task, and you can specify the number here. So in this program, it has been set as 3. Okay, we can change that. When we'll run the program, we'll change this number of the reducer. Once you have that done that, what you specify is you specify the map logic, whatever you are going to execute as part of this particular implementation. So you tell what is the mapper class. So you set this is the mapper class, and this is the reducer class. For this particular flow, guys, you guys may have the question that why we need to set that, because everything is there in the same program. That may be correct, right, for this one. But generally, when you work on a Hadoop Mapreduce program, it's not just one single Mapreduce implementation you do. You are going to have kind of the chain of the Mapreduce job. So you will have different map class and the reduce class, and if you want to identify which Mapreduce should run as part of this the Mapreduce flow, you have to set that as the map class and the reduce class. Okay, now if you see here whatever I highlighted, this is the reduce class where you have this reducer, and this is the map class what you have mapper. Now if you want to implement the combiner class, all you have to do is whatever the logic you have written in the reducer class, you can just pass it to same to the combiner class. So that way it will just do the local aggregation of the data on the mapper output. Okay, and then if you are implementing any partitioner, so you implement this partitioner class and you specify what is the logic. We'll go back and see what is the logic for the partitioner. Okay. Now, once that is there, you set all these configuration objects like what is output key class and what is output value class. So like this is the text and the integer, because it's going to be the word count. And then input format, the input data which we are going to write as the text input format. So what it means is the data is going to read as key value pair, and the key is going to be the line offset, and the value is going to be till end of the the new line character. So that's going to be the value. And then this is the way how you provide the input path, guys. So it is argument 0 is the input data set, and argument 1 is the output data. So this part, guys, almost similar to what you had in the word count, except that this particular stuff what you are seeing the combiner, and this new class this stuff what you are seeing the partitioner. So we are going to see these two things up here. Okay. So now when it comes to the mapper, the logic what we have is like you are going to have your input data set, and the input data set you are going to split based on like if it is the space separated. So you will split the data based on the split, and the data is going to be basically a different word which you are going to have here. And in the mapper, what you will have is basically you have this combination. Each word will have whenever you will see the occurrence, you just count it each time, and that's what you are going to have the output of the mapper. Okay. Okay. Now, once you have this one, what you have is here is like here is the logic, like what is the get partitioner which you implement. So what this get partitioner takes is it takes the key and the value pair. Apart from that, it also takes the number of the partitions which you have. So in our case, the number of the partitions which we want to run is like it has the 3. So there are 3 partitioner which we want to run it here. You can set this number as many like you want to run based on the availability of the number of the reducer slot, right? So now what you are implementing in the partitioner is like suppose if you have 3 reducer. So in our case we have 3 reducer which we have, and then you have multiple mappers that are running here and processing the data. So now what you are telling that if anything that is like if any word that is equal to Hadoop, right, whether it's coming from this mapper or this mapper or this mapper or any mapper, right? So all these word, if it is Hadoop, it is going to be the reducer number 0. So what it means, if it is this 0, this is 1 and this is 2. So what it means is all these word which are equal to Hadoop, it's going to come to the reducer number 0. Okay, so like that way it's going to happen. Similar way this one. Okay, then what you are telling, if any word that is equal to the data, so that's going to be the reducer number 1. So like suppose if this output is data, it's going to come here. This mapper is going output data is going to be there. So there, and suppose this mapper is going to be here. Okay, anything else like which is not Hadoop and the data and that's getting processed by the mapper, so all of them is going to be aggregated by the reducer number 2, and that's basically the default reducer which we have, the third reducer. So that's the way how although diagram looks complex, guys, it's not so complex. I think I made it complex here in the diagram. Let me clean this. Okay, so what it means is like if your word is equal to Hadoop, you are setting that reducer to be processed as 0. So means the first reducer. If it is data, reducer number 1. Anything else, it will be processed by the reducer number 2, right? So that's the way how you segregate or how you partition your data with the logic which you have coded, and based on this logic, your whole MapReduce is going to send the data. So what you will see that output of this reducer, it will just process the Hadoop. If this will process the data, and the last one will process all the stuff. Okay, and then in the reducer, you just implement all these things again. So you keep incrementing the value, and that's what you send it to the output key, and it just output the data. Okay, rest all the things, the map and the reduce is going to be the same signature. So I'm just going to leave that for now, because we had the detailed discussion how the map and the reduce pass the data. Okay, in the last class. Okay, why do we need to set the number of the reducer in the main method, as your get partition method is anyway deciding? Okay, so that particular value we are passing because from the driver class how many number of the reducer we have, right? So it needs these number of the reducer to basically implement this number of the partition, so that will be passed by the framework based on the value which is to find the number of the reduced tasks. Okay. Okay. Okay, good. So this is our September 26 batch. Okay, so let me clean this. So okay, let me close all this. Okay, so this is the advanced MapReduce. Okay, so we created this, and let me get quickly the code for you for this custom partitioner. So advanced MapReduce and custom partitioner. Yeah, copy. So this code is almost similar, guys, what we did for the MapReduce, except that it is having the logic for implementing the partitioner logic. Okay, apart from that, rest of the things still remain same. Okay, so this is the same program we have. Okay, so anybody wants to increase? Let me increase this number of the partitioners. So okay, let me increase this number of the partitioner as 5. Okay. Okay, and let's add something here, guys. Okay, so we have the two data set here. Let me add something more. So whatever you want to do, you guys, you can add it here, right? So you can have like, if my key is equal to something like, excellent, right? It should go to maybe this is 0, 1, 2. Okay, and if my key is equal to good, send it to the reducer number 3. So since what we set is the number of the reducer as if you come here, the number of the reducer I have set it as 5. So I have to basically code the logic for all those, like how the reducer should go. So I'm telling that if my key is equal to Hadoop, let it go to the reducer number 0. If it is data, reducer number 1. If it is excellent, go to reducer number 2. If it is good, let it the reducer number 3. So how many reducer we have already used? 4 reducer. After that, anything else we don't care, right? So all those things, let it go to the reducer number 4. So that will be the 5th reducer which we have. Okay, so that's all the logic we have here. Now what you have to do is you have to okay, so is this program going to run, guys? No. Okay, so is this program going to run? No. So what we have to do is we have to attach the reference jar file. So what you have to do is you have to go to build path. So I'm showing this again, guys, one more time, just for the people who have not not done this Mapreduce yet. So just to make sure that you do that. Okay, so file system user lib, and then you go to Hadoop. Okay, and then whatever the jar files you get it here, copy it all. Okay. Okay, what happened to this, guys? Okay. So rename, guys. So always this class name and the the file name which you save should match. So that's what we have to do that. Okay. Okay, so now once I have this, guys, so I think we are good to basically run this program. So without any further delay, let's go ahead and create the jar file. So do the export jar file next, and okay, September batch. So Mapreduce demo. So let's do this custom partitioner dot jar. Okay, so do it next, and with partitioner. Okay, so this is again going to be a recap, guys. So the people who are missed the last class, you can do that. So you go to the Mapreduce and you will see this particular stuff, ls minus lrt. So this will show you the latest data set. Okay. So this is the custom partition and the logic. Okay, we have. Now we have to move the data set, guys. So we have to create a quick, not this is SQOOP. Okay, we don't have the data set. This is the data set. Okay, let me create quickly one data set, guys. Gedit, and data set is custom partitioner .txt. Okay, so let's add some word here like Hadoop. Then whatever we have the data. Then we have excellent. Okay, then we have good. Then we have average. Then we have bad. And then we have day. We have any kind of data set, guys. I just want to have it. Okay. And we have Edureka. Okay. Now you take this data set, create a little bit more, and you will see how the data get okay. So save this data set, file quit. Okay, so you have a data set which you can send it. Okay. Okay, so now what you do is let's move this data set inside that HDFS. So you do Hadoop fs -ls, and then do we have our batch folder created there? Yes, September 26 is there. So we'll create Hadoop fs-mkdir and September 26 batch and advanced Mapreduce, and then inside this partitioner. Okay, and then move the data now. Hadoop fs-put and take this data set. This steps should be clear to you guys. So all I'm doing is I'm moving the data set inside the Hadoop file system so that in this data set inside HDFS, so that we can give this input data set for the advanced Mapreduce processing. Okay, so now let's do that. Hadoop jar and get the jar file name. So this one. Then you have this partitioner, and let's create the output as well. The output. Okay, so hit enter. Okay, so it's running. It's slightly taking time, guys. I'm not sure why. It's a small data set. Anyway. Okay, so final it is processed. Now, if I go back here, okay, let me show you that in the job tracker. Okay, sorry, on the HDFS. No. Okay, so let me go to September 26 batch and advanced Mapreduce. Okay, partitioner output. Okay, so how many files we got created here, guys? Can you see this, guys? So how many number of the reducer you have specified? So those many number of the output file will get created. Okay, so if I open this particular file, guys, that's the reducer 0. What kind of the data we will have inside that? Any guess? Okay, Sarna says Hadoop, Pradeep says Hadoop. Okay, okay, so let's see that what kind of the data we have. Okay, so we have Hadoop that occurred 19 times. So you see here in this reducer output, only you have data for Hadoop. You don't have any other output that's coming here. If you see the one, it only counted the data word, and that's what you have the output. If you go to 0, it's only excellent, and that's what it came here. Okay. Similarly, good, it was done by the 3, and rest all of the data it got processed by the last reducer, and that's what it did the count. Okay, so that way you basically segregate the data with the help of the custom kind of partitioner. Okay. Can we see in the browser how the partition? Yes, you should be able to, right? So those things I like generally don't show you here. Okay, but you can always see it here. So if I go, I think this is the something which just now ran. No, it's fifth data. Let me refresh this. Return job. I think this is the data set. I'm not sure what is the date time here. Okay. Yeah, so you can see that very much here in the job tracker as well, Mohammed. Okay.